Hi guys, my name is Arvindh. Welcome to 6th grade math with all STEM. Today we will be discussing algebraic expressions. This video covers the basics of variables, exponents, coefficients, relationships between all terms in an expression, properties of operations on numbers, how to evaluate these expressions fluently, and understanding the number relationships of these expressions in word problems. As always, our videos consist between 8 and 15 review questions. Each one is timestamped in the description box. If you get a question right, feel free to skip to the next timestamp. Otherwise, go ahead and watch the explanation after each question. If you want to review certain topics after this video, we have a links to further reference page in our description box. On this page, we have a link for each question, so you can dive deeper into the challenging ones. These links are great for extra practice. All right, let's get started with the first question.
Hey guys, so before we jump into problem number 1, I just want to go over these really quickly. So we're going to be covering how to write numerical expressions with or without grouping symbols and whole number exponents. We're going to write, read, and evaluate algebraic expressions, apply the properties of operations to generate equivalent expressions without exponents, and we're going to lastly identify when two expressions are equivalent and justify with mathematical reasoning. Okay, so here's our first problem. So consider the following expression, 6 plus 3 squared, and the quantity of 6 plus 3 squared. So evaluate each expression and explain why they have different answers. So I've given a little PEMDAS chart here in this white area, so you can use that and explain why they have different answers. So pause now, and in a few seconds, I'll reveal the answer. Ready? 3, 2, 1. So I'm just going to read through the answer box over here. So let's first start with 6 plus 3 squared. So according to PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction, we have to square the 3 first. So 3 squared is 9. So we're going to get 6 plus 9, which is 15. Now, when we have the quantity of 6 plus 3 squared, what that means is that I have to solve 6 plus 3 first, because we have to do what's in the parentheses first, and then we have to do our exponents. Okay, so when I solve what's in the parentheses, I get 9 squared, and then when I solve that, I get 81. So when I did 6 plus 3 squared, I got 15, and when I did the quantity of 6 plus 3 squared, I got 81. So these are really different because of the order of the operations. Make sure that you always follow your PEMDAS steps in the correct order, otherwise you can get two completely different answers like these two. Alright, now for our second problem. The expression 4 times 4 squared times the quantity of 8 times 2 and 4/5 are equivalent. Show that the two expressions are equivalent. Describe the steps that can be applied to 4 times 4 squared times 8 times 2 to create the equivalent expression 4 times 5. So I've given another diagram of a PEMDAS chart here, so you can use that to help you solve the problem. Pause now, and in a few seconds I will reveal the answer. Ready? 3, 2, 1. So here is our rewritten expression, which is 4 times 4 squared times 4 squared, which equals 4 to the 5th. So you can read through the answer box, or you can just listen to me say it. So 4 is equal to 4 to the 1st. And then we have 4 squared. So remember our exponent property. When we have the base that's the same, we can just combine that by adding the exponent. So 4 to the 1 times 4 squared equals 4 cubed. So now all we need is 4 squared, and that will get us 4 to the 5th, right? Which is what we need to get. 8 times 2. That is 16. 16 is also 4 squared, right? So there we go. 8 times 2 equals 4 squared. So our answer is going to be 4 to the 1st times 4 squared times 4 squared. And this is going to get us 4 to the 5th. All right, problem number 3. So we have to create an expression or number sentence using the phrases listed below. 7 less than 3 times a number and 6n squared. And I gave a little definition down here. An expression is a combination of multiple terms that isn't set equal to a certain value. All right, so pause the video now and take a few seconds to solve it, and then I'll reveal the answer, okay? Ready? 3, 2, 1. Okay, so for part A, it's 3x minus 7, and part B is 6 multiplied by the quantity of n squared. So once again, you can read through there, or you can just listen to me explain it. So 7 less than 3 times a number. So less than and minus are two different things. 7 minus x is this, but 7 less than x is this, okay? So just note that those are two different things. So 7 less than 3 times a number. A number we can represent by n, a, x, even, I don't know, theta. That's a Greek letter. We can represent an unknown number using a variable, which is just any symbol you want to use. So I used x, but you can use anything you want. So 3 times a number is going to be 3x. And 7 less than 3 times a number, it's going to be 3x minus 7, right? Because it's 7 less than this. So that's how we get A. And now B, we have to write this in words. So 6n squared. So we have n squared, and we're just multiplying it 6 times. So 6 multiplied by the quantity of n squared. You don't have to say quantity, or you could have, but it pretty much just means the same thing. The quantity of n squared is just this versus this. They're the same thing, okay? But they're not the same thing when n has a coefficient. So this is not the same thing as this. Okay? Keep that in mind, but yeah, these should be both of your answers. So we have two mini problems in question number 4. So part A is saying that Josie earned 65 bonus points. Norma earned B more points than Josie. Choose the expression that shows how many bonus points Norma earned. And now part B says Ayana earned 85 extra credit points. Tyrone earned E fewer extra credit points than Ayana. Choose the expression that shows how many extra credit points Tyrone earned. So write an expression for both of these, and we will check in a few seconds. Okay? Ready? 3, 2, 1. So once again, you can read through my explanation, the written, or you can just listen to me say it. So Josie earned 65 bonus points. So whatever number that we're given, that's going to be called our constant, okay? So 65 is our constant. Norma earned B more. So B more is definitely a plus in there, right? B more points than Josie. Since we don't know what B is, we're just going to represent it using the variable B. So it should just be 65 plus B. And that is what we have. Okay. Now for part B. Ayana earned 85 extra credit points. Once again, we found our constant, 85. And Tyrone earned E fewer. So E is going to be our variable. Fewer means what? A minus sign, right? He earned E fewer. So it's going to be 85 minus E, because it's E fewer than 85. And that's what we got here. All right, let's look at our 5th problem. So the expression 2m plus 10c gives the amount of money in dollars a dessert store makes from selling m muffins and c cakes. How much money does a dessert store make from selling 3 muffins and 4 cakes? So I've given our PEMDAS chart here again, so feel free to use that when you solve this problem. Pause now and we'll check in a few seconds. Ready? 3, 2, 1. So our answer is $46. Feel free to read, or you can listen to me explain it. So 2m and 10c. or I should say plus 10c. This is our expression, and this will set equal to dollars. Okay, that dollars represents how much money we will make. So we're selling 3 muffins and 4 cakes. Okay, so here we basically have 3 equals M, 4 equals C. So when we plug that in, we get, let's just box this, 2 times 3, right? Because we put 3 as M, since 3 equals M. And then we have 4 as C. Oops, why did I write C? Let me erase that. Okay. Now we plug in 4, and that's our equation. Now let's solve it. 2 times 3 is 6, and 10 times 4 is 40. 6 plus 40 is 46. And that is how we get our answer as $46. All right, let's do our 6th problem. So we have to produce an equivalent expression for 3 times the quantity of 2 plus x. Okay? So equivalency, our definition for equivalency is defined here in the white area. Equivalency is a situation where one term or a group of terms is equal or equivalent to another term or group of terms. An equation always displays equivalency. So when I say equivalency, that can just mean 3x equals y. This equal sign is equals sign. Okay, I totally messed that up, but we're going to keep going. That equals sign shows equivalency. Equal sign, equivalency. Okay? So pause the video now, and in a few seconds we will check our answers. Okay? 3, 2, 1. Our answer is 6 plus 3x. So we can just use what I like to say, the laws of distribution. That sounds so fancy, but that's basically just your distributive property. So we have 3 times 2 plus x, okay? We're going to distribute our 3 to the 2 and to the x, okay? So now we have 3 times 2 plus 3 times x, okay? Now let's solve this out. 3 times 2 is 6, plus 3 times x, which is 3x. Now we have 6 plus 3x, which is our answer. All right, let's do our 7th problem. So some high school students were disagreeing about their Math 1 homework. One student claimed that 2x minus 3 quantity squared was equivalent to 4x squared plus 9. The other students said, no, 2x minus 3 quantity squared is equivalent to 4x squared minus 12x plus 9. Help out these high school students. Who is correct? Explain how you know. So we have our PEMDAS table again, and I defined the term property on the bottom. So property is a rule or set of rules for specific operations in given equations. So pause the video now and determine who is correct. And in a few seconds, we can check our answers, okay? 3, 2, 1. The other students are correct. And by other students, I'm talking about the 4x squared minus 12x plus 9 people. So let's use our distributive properties again. So I know this is just 6th grade math, and this is a pretty advanced topic, but hang in with me. So I'm going to make a little foiling table. So when we multiply two equations like this, this is basically just 2x minus 3 squared, right? So we have our two terms that we're going to multiply. So this is called foiling. When we foil a linear equation, which just has 1x, to a quadratic, which has this little squared term. Okay? So that is what we call foiling. And so I'm going to FOIL this out. So I want to put one term here, my 2x. My 2x goes in here. By the way, this is like a little tic-tac-toe grid. And I have my minus 3. And this is our first equation, right? 2x minus 3. Now I'm going to do the same thing for our next equation, 2x, and then the minus 3. Now, just multiply straight across. So 2x times 2x is 4x squared. 2x times negative 3 is minus 6x, right? 2x minus negative 3 is minus 6x. And negative 3 times negative 3 is 9. So our equation becomes 4x squared minus 12x plus 9. And this is what we call a quadratic equation. So I know this is really far advanced, but this concept of using this tic-tac-toe grid is actually quite simple. If this is really confusing for you, then you can just simply do it like this. You can do 2x times 2x, and then 2x times negative 3. Then you do negative 3 times 2x, and then negative 3 times negative 3. And then when you have all these terms multiplied out, and then you combine them, you'll get the exact same answer, okay? So this definitely requires a lot of practice, but soon enough you'll get the hang of it.
I hope that this was a good review of these topics. Like I said in the beginning, make sure to check out our links for further reference page in our description box down below. Did these questions help you out? Do you have any other questions? Let us know in the comments below. If this video was helpful, please make sure to like, share, and subscribe. Thank you for watching, and I hope to see you guys in the next video. Bye.